Okay, so let's take a look at this second problem here. This could be a little tricky because you see the outline. Once again, as always, you always start by looking at your starting material and try to see if where that might be in your final product. And I didn't do this on purpose. You can actually see two scenarios. Either these 5 carbons are your starting material, or these 5 carbons are your starting material. Now, the only way that you could, the thing that should make you think twice about these 5 carbons being the starting material is you're making a bond between this end carbon here and these 3 carbons. And so the only way that we can do that is through a Grignard or through the terminal alkyne. If we did a Grignard, that would make the functional group either end up on this carbon or this carbon, depending on whether we turn this into a halide or we turn it into a ketone, or I guess aldehyde, in that case, and then make this be the Grignard reagent that we add. So in that case, it's not going to work. Well, it's not going to work in make these be those carbons. If you're thinking that way, it's not quite what's going on. And yet it is the right way, I just realized, because it is the right path to do a Grignard, but it's not these 3 carbons where you need the OH over on this carbon, but rather this carbon with the OH is this carbon. In other words, this is your starting material. And so in that case, you need to form your bond between 3 carbons and this one and end up with a functional group OH. Turns out that's great. At that point, we know the perfect reaction. It's the same one we talked about in the previous video. Grignard reactions add an R group to a carbon, and that carbon that you added the R group to turns into an alcohol. So we need this carbon to become some sort of carbonyl compound, C double bond O. Because if this becomes a C double bond O, that C double bond O, after reacting with the Grignard reagent, will become an alcohol. So we need to turn this into an alcohol somehow. into a aldehyde somehow, like this. Because if we can make this become an aldehyde, then through the addition of the Grignard reagent, so when you take this approach where you turn your starting material into an aldehyde or a ketone ester, whatever, if the starting material becomes the carbonyl or C double bond O compound, you can actually just throw in a sort of pre-made, so to speak, Grignard reagent. In other words, you don't have to just start with pure magnesium and ether. You can start with Mg, well, technically the Br should be on the other side, Br, Mg, and then whatever the group is. In this case, we want this 3-carbon structure to be added. And to be complete, you should always remind your reader of your synthesis that it's in ether, because if it's not in an aprotic solvent, it's going to possibly catch fire, or at the very least, destroy the Grignard. Then you add water, because as always, once you mix this Grignard with this aldehyde, you'll end up with that negatively charged oxygen intermediate that needs to be protonated with some water. Maybe even some acid, just to be sure that you eliminate everything. This is probably the more common reagent, but if you just put water, I'll accept it generally, because I think the book says that most of the time. And once you get that, what you've made is the final product, actually. You've made this become an OH, and you've added that. And so that's just this, but I've kind of wrote, this bond right here needs to rotate around. Needs to be rotated around. But that's the final product right here. So the real question then is, how do we make this from this? How do we transform this alkene into this aldehyde? And once again, you just think about the recent reactions you've learned in these latest chapters? Have we learned how to make aldehydes? Now, I think I saw some people trying to use ozonolysis. Ozonolysis does make aldehydes, but the thing is, if you use ozonolysis on this alkene here, you're going to shorten the carbon structure, because ozonolysis cuts, if you remember, it cuts the double bond in half, so you would turn these 4 carbons into a double bonded O aldehyde, and you would get this carbon, which has 2 hydrogens on it, with a double bond O. That would be what's called formaldehyde. But neither of those are this, so it's not the right carbon structure, so it can't be ozonolysis. So assuming you got to this point, you knew that you needed a C double bond O for the Grignard, but you're just trying to make it. Don't force it. Yes, ozonolysis causes aldehydes, but think again, what other things have we learned? We've learned that you can make aldehydes through oxidation, at least carefully picking what reagent, but through oxidation of an alcohol. So what alcohol would that be? It would be this alcohol. So we need to find a way to make this from this alcohol, and a way to make this alcohol from this alkene. And it turns out that is it. Those are the intermediates that would best work. And so what are those reagents? It turns out those reagents are because remember, we've learned that we can turn alkenes into alcohols for various ways. A lot of those ways are Markovnikov, but this position, if you don't remember that terminology, in other words, most of the ways we learn about alkenes turning into alcohols put the OH, or at least 2 of them I should say, put them at the more substituted carbon, but we want the one that puts it at the least substituted, and that was hydroboration oxidation. So you take the borane in THF solvent, and then add your oxidizing agent, which is a mixture of sodium hydroxide and peroxide. That will transform your alkene into a primary alcohol, or I should say the least substituted alcohol of the 2 positions the OH and H could add to, or the OH could add to. Then you oxidize it to an aldehyde. Remember, you have to choose correctly. If you use acidic chromic acid, or I should say, if you use a aqueous acidic chromic acid reagent, that would oxidize it all the way to a carboxylic acid. So we have to use one of the others. The easiest one for me to always remember is to just put PCC in CH2Cl2. Now keep in mind, you need both of these, because this is a solid that really, if you just dissolve that in the alcohol, that's not enough. You do need to place it into the methylene chloride or dichloromethane solvent. That is needed in the reagent list. At least I require it to be complete. And that would turn it into your aldehyde up here. And then this reaction turns it to the product. So that's it. This. So what would that be summed up overall? It would be BH3, THF, followed by H2O2. That's the more common way or order of writing it. NaOH, followed by PCC in CH2Cl2, followed by adding a Grignard reagent, already turned into a Grignard, specifically this one, followed by the last thing, water. Hope this was helpful. See you next time.